Welcome back. Today I'm going to be continuing to work on KanoScript. So today I would like to work on self-referential structs, right? So basically, made an example here. Let me change this, right? So let's say you have a linked list. Usually we'll want to have a pointer to the next list, right? Stored in the object itself, or the struct itself. Right, so if you're familiar with a linked list, obviously you would know how that would work. There's no way to do that currently. Well, not no way, but there's not a good way to do it currently. So basically, here I define a struct list with some sort of data in it, can be whatever, and then also the next one. We can see when I go to compile this, expected type, but found ident, right? Because it sees it as an identifier, because it's not added to the list of structs until after all of this is parsed. So to get it to work, basically what I'm going to do is just right when we counter this, we're going to push it to the list of structs, right? The symbol table, whatever, to reference it. So then we can reference it within this struct, because we don't need any further information on it, right? We don't need to know the size of it, the fields, anything like that. Right, we don't need that because we're not using it in here because we cannot define like default values or anything like that. So obviously it doesn't really matter. Yeah, so that should be pretty much it. Currently, we could do something like this, right? All of them are pointers. When you declare a list or whatever, it's a pointer to it. And we could do that, but the problem is we don't have any information on what the type is, you know? And we can't cast it, right? We don't have that ability yet. And also, it's just not very clean, right? So we could technically do it like this, but it'd be much nicer if we could do this. So let me actually move it up here because I think that looks better. So I want this to be able to compile, right? So just once we encounter this, we'll push it there, and then we'll modify it directly from the struct itself instead of from this, right? So let's go ahead and do that. Also, I noticed there is an extra new line here, which is not ideal. Let's see, so that's going to be in the front end. So when we parse struct, let's see, I forget, some struct. Structure. Alright, let me just search for parse. Okay, right here, so we should be able to find it in here. So if it is a structure, then we do all this stuff. Okay, so while structure equals that, so we get the structure, and we do this, open curly. Right, so this is, what is this? Parse, right, so that's variable declaration. So that's maybe not what we want, because we want to look for when we, not the ident, but instead when we counter this right here. So what we have to do basically is just move this. So we push it to the symbols. I think that's where we get it. So what we want to do is just take it and do this, right? So we need to do it up here, and then we want to modify it from there directly. And we can append it to the struct, so this is where we compile it, right? So that can be done after, and that is fine. But what we want to do is go here. So we get the name. Right after we get the name, bam, we can append it, right? Equals node value.structs. Yeah, so we can append it there. And then we can modify it directly, right? Because we will need further information on it later. So it'd be nice if this could be a reference. But it is not. So I don't really want to change it all. So let's see, we can go through this, and then when we modify the node value, we just need to basically replace it. So let's see, we don't define any structs within here, so what we can do is just at the end, right, so this might be super simple. At the end, and if we get rid of this, we can basically just look. We can first of all assert that parser.symbols.count is greater than 0, and then we can just modify it from there. And what the heck is this? Okay, so we can basically just set parser.symbols.data parser.symbols.count -1. So that should grab the top one, and then we can set it equal to symbol, right? So we can, because the symbol is this, so the value is that, so that's like a copy of it, so we need to set the symbol value again. Right, so we basically are getting kind of repetitive here. Right, if this was a reference, we wouldn't have to do any of that. But it's not set to that, so that will be probably a to-do thing, right? But we can set symbol.val.structure equals node value structs, right? So we have all the proper information there, and that should be pretty much it. So if I compile this, and I need to add a message to this, and that is not how you do that. Okay. Yeah, that is not a thing. And then we need to do, let's see. There was an issue with the symbol table. And let's go here, and let's try to run it. Break the type of found item, so it still did not work. Kano. Let's see, 4. Yeah, so it's still there. So that did not work. Why is that? We parse the variable declaration, and we append to that. Right, so it's in the parse variable declaration that happened. Let's go to that function. And let's see, what do we do here? You know what? I think what we do is struct. I think that might not use the symbol. Yeah, it does not. I did not update it. So we need to pass just the parser in there and use the symbol tagging instead. Parser. No, we want is struct. Yeah, so this will token peek, and then we want to do all of this stuff. Why do it like that? Okay. So what we can do is view compare. Yes, we don't want to use structs. We want to instead go through the symbol table. So let's do parser. So we need to update this to use the parser. Parser, and we can do parser symbols count. And this is parser symbols data. Dot value dot structs. Is that what it is? It's something like that, right? So if so let's see, we want to first check just set the current symbol. Symbol close parser symbols dot data I. And then if whoops, I did not mean to do that. Is struct right to that. Let's see. So first of all, we can take if symbol dot type equals symbol struct. I think it's called. I cannot type symbol struct and view compare. This can just be symbol dot value dot structure. I think is what it is. That name. Then return true, right? So it is a struct in that case. So it's something like that. I think we'll have to update the header file as well. You mean val? Okay, I guess it's just val. So I guess I use. Yeah, I'm not very consistent, unfortunately. Yeah. Use variable structs. Where do we? Oh, shoot, we don't use structs at all. Yeah, so we don't need to set that thing. And it did actually compile. And then it worked. Okay, so hopefully it does actually work. Now there was another issue that I was noticing while I was testing stuff. So this might not actually work, but I think if we set a list, right? So it's just the list equals. So we can set set it to nothing. Right, now I don't think this is gonna work. Data.next data.data equals 1. Let's see if I do that. Yeah. So it's saying this. I'm not sure why. There's something to do with the way that we set the expressions up. I can expect an equal, but it's a dot. So I messed something up there. Unfortunately. So I need to figure that out. But yeah, so it looks like that did work. So let me try to get this working now. Expect type, and then this should actually work. Self-referential structs. Let me actually commit that. I'm not gonna push it yet, but git commit. Let's see. Implement ability for self-referencing structs. Issue with struct right. So it's just, I'm not sure why. I need to look at it. Let me just run it again so I can see what it is. So I say type equal, but kind of type in. Right, and that is on when we're doing that. So we need to look at in the parse, right? Just go to the parse, and this is where it's going to be. It's going to be in here. If token type equals colon, then it is a variable declaration. Else, parse reassign. So this is the left side of reassign. So field reassign, we do have that. So parse reassign left. So for some reason we are expecting an equal sign. Let's see, token peek that. Let's maybe look at what it fails. Enable run okay. Yes. Okay, and expect type equal. Alright, let me break on parse reassign left. And run. And let's see, let's step through here. Is it in here? Alright, let's continue to the next one. Parse reassign left again. So it's not there. Print, can I print tokens? Let me go next and print token. So that is alloc. So it's allocating stuff. Why is it allocating stuff? Oh, it's a type int. Okay, wait. Alright, continue. Continue. Alright, so it broke there, so I don't know what that was. Can I do... Wait. Okay, it just failed. So... Expected type. Alright, that's here. So it called expect token. Can I just search for token type equal? Right, where are we expecting an equal? In here, so in parse. So is it failing here? Equal, and I'm just gonna do that and equal 2, right? So we should have an equal 2 at the end. Right, so it's just what it has the time. Equal 2. Okay, so it's not there. Type equal. Is there another place? Like token here. Okay. Ooh, so we might be getting in here. Let's, I mean, it shouldn't be in here. Let's see, F equal, then equal 2, right. Probably the best way to do this, but, and okay. Did not call that at all, so it's definitely not there. Okay, so it's right here, actually. That's where it's going to be. Field reassigned. So it's expecting an equal. So we need to consume the ident. Is that what it is? Token consume. Oh, that's right. Does that fix it? Is it an issue with that? Because I guess I didn't really test this. Okay. So it looks like that's what it was. Let's see. Consume, I don't know. Consume ident. Right, so we should have that. So if I go in here, and I set, not the, yeah, so we set the data equal to 1, and I'm just going to exit with data.data. We'll make it something that would not be. Primary cannot be no. What? Okay, that's interesting. 790. And front.c, that's here. Huh. Oh, shoot, because that's in this function. So it has a null file name for some reason in the structure. Ooh, okay, so I messed something up. Oh, shoot. Actually, that shouldn't be it. Struct. Where do we call it? Get struct. Sure. So we call it in here. Oh, shoot. Actually, expect token. Type tokens, token type equal. So when we go there, where it failed at, right? So this must be. We don't get it here. Let's run GDB. Okay, can I see it? No. Okay. Can I break on 780 down? Break on front and .c 789. Run. And then tricks. Can I do that? So called from parse primary. Right here. Okay, 668. Just trying to get this structure. And what is the structure name? So can I print the name? Data. Oh shoot, that's not the structure name. Oh shoot, I made a mistake here. For value. Hang on. Okay. Yeah, I see. So that is not right. It's a dot. Yeah, we can't get the structure from that, so we need to get the structure from, shoot. Get structure. Okay, let me think about that. So we need to get, Right, so I have an issue in there, for sure, because it's looking for the name of the structure, but we're passing the field name. Actually, is it the field name, or is it, yeah, it's this right here. What if I do list, right? Right, so I don't know if that's what it was. Yeah. So the file name is null, first of all, and then also we're passing the wrong thing here. So we want to, well, no, we're not passing the wrong thing, are we? We're just getting the structure incorrect. We need to find in the symbol table the structure with that name, right? So let's pass the parser here. We need to do basically the same thing, right? So get structure. We need to do the same thing that we did for a struct. So this needs to be parser. We can go through the parser symbols dot count, parser symbols dot data I value dot structure, and it's val dot struct dot name. So first of all, we need to check if it is if I'm not gonna make any variable for it at the moment. Dot type does not equal symbol struct, and continue. Otherwise, we'll do this, and we'll do that. We don't want the structure name. We want let's see, what does that do? That probably would be the same thing, right? Shoot, actually we have some broken stuff here. So we need to update the header. Well, no, we need to, first of all, go to all get structure occurrences and pass the parser. Alright, so I guess that is it. And then we have that. That is wrong, we're returning the wrong thing. Symbols dot data I dot val dot structure. Well, actually, it's a variable, right? So that's really what we want to return. Alright, so what we want to do is we want to find out if it's a variable. That's what it is. Right, so I'm just trying to, right, because we're passing a variable from here. Right, so that's what we are expecting, right? I just want to make sure. Get structure. What was the other place that we called it? In, not there, the other one. In here. Okay, so we actually have, yeah, value var struct name. So that's what we want to use here. We can, if we get the struct name, then we just get the variable. Then we don't have to change that necessarily. Get struct. Let's see. So if we do this, right, and we return symbol struct, right, structure name, we return that, right, and when we call get structure, we want to call it on the variable, right? So we can do variable struct var equals get variable expr location and then parser, and I don't remember exactly what we pass here, but we can get expr value dot field dot structure. This can be struct var dot value dot struct name, right? And then we have the access to the struct, right? So that's pretty much what we want. Let's see, does that compile? Yeah, so we need to update the header file as well. Yeah, struct. Get structure, so this is parser now. Parser, okay. And unused variable structs. Alright. Yeah, so we can get rid of that then. Variable struct var set but not used. Alright. Well, we do use it though, so I don't know what that means. Exprs has no value.var. And actually it's just dot struct name, right? What's the declaration? It's just get var, right? Okay, that compiles. Still failed. My printf the struct name. You slash n. You arg struct var dot struct name. If I do that, does not print anything out. Why? I do that. is that? Oh shoot, now it's unknown variable. Okay. Yeah, but it's failing because of that. So the location, that's messed up. So let me go to there. Figure out why the location is incorrect. Oh shoot, it's because I'm overwriting it. So location equals token.love. Right, so I need to do that. Unknown variable data. Okay, so we're grabbing the wrong thing here, I suppose. Well, we shouldn't be. Like it's list. And the next one is a dot, and we don't consume anything. We print that. View print actually. So I'm guessing that's what it is since it printed out there. I just want to make sure. You are value.init. Oh, okay, no. Alright, so why is it data? Is there... Wait, so case ident. Hang on. Case ident, so that's in here. Token.type is here. Switch over that, and if we get to an ident, and then we have a dot, yeah, so I don't know where that's coming from. Should I run a, well, let's bring out the token here. You are token.value. So they might not all have that, so it might actually cause some issues, but data. Why is it double data? Oh shoot, actually did I mess it up? When we're creating the struct, is it messed up? So that could be it. So type struct. We just go here. Did I mess that up here? So the struct's name is that. It could be on the struct declaration actually. Because this is probably fine. I would assume that's fine, but it's going to be in the declaration of the struct that we have an issue. So let's go to, if it is struct, get that, and then get the structure based on the value of our struct name. And we append these. That should be fine, but that's that's the variable deck. So it's not there. It's going to be on the var reassign, right? Where do we have that? Right here. So we do that. Parse reassign left. Because we set it here, don't we? Not here, but right. Well, token type dot. Yeah, on the function declaration. We set this function name. No. It's not a function. It's where is it? The struct one. Oh, right here. So expect token equal. Let me append that. Parse reassign. Yeah, so we mess it up in there, I would assume. So token type dot. That's not right. Token peak 1. Name token. Where do we use name token? So the field dot structure is it. Right. That's the structure. Let's see, name token. Where do we have that? So token type dot. Name token is the ident. Field reassign. Right. And then the other part is, oh shoot. Hang on. What is this? View. I cannot type. View print view art name token value lu dot ident. I print that out. What do we got? This, and that is correct. So we set that properly. So that is here. That is the field structure. But then we assign that. Expect that token, and then the top one is what we consume here. So we need to set the value. This is the ident, so we have to handle the ident here. Right, and we're not doing that. How can we handle that? Right, we need to take this, and this is the value of the, this is the field that we are changing the value of. Node value, field value. What does that mean? We're just appending to it. We need to set it, actually set it, right? So let's do, let's set this to the new name token, right? Token equals that. So let's do I equals 0, I is less than node value dot, so what do we have for that? If I open up a new one, right, so, node value, we have struct, right? Well, no, we have, this is a variable. So, hey, what do we have? Node value dot field. It's a field, yeah, it's a field, which is field. So what is field defined? Field has a value, a var name. So that's what we want. We're going to set the var name equal to that. And then, yeah, we just set the value. Okay. So, hey, we just do node dot value dot field dot, or not field, but dot, yeah, dot field dot var name equals that. And that's it, right? Equals token consume dot val dot value dot. Okay, we have that. Alright, unknown variable data. So now we can get to that, right? So get struct here. And here we're doing some weird stuff. So we get that, and this is what? This is parse primary. So that's data.data. So that's what that is. It's not called data, it's lists. Lists. Echo that. 12. And that actually worked. Okay. Where are we printing stuff out again? Oh, it's right here. Yeah, so that was just that was actually a syntax error. I think it was failing on other places as well. So that was like something we needed to fix anyway. Let's see. So then can we set list.next equals a new list. So let's make a list. I don't know if we can have items, so I'm just gonna call it list equals data equals 15, and then the other field will be set to 0. So we can do that. List.next equals list. Can we do that? Can we do that? Token that. Alright, I put a semicolon. That is not allowed. I'll put another semicolon. That is not allowed. Alright, then complain. Let's do 10. Right, so we can't do like dot data dot whatever because that is invalid because of the way I'm handling it currently. So that's a to do, right? But if we set it to list.next and then we do temp.data, shoot, we can't set it to this. So we need to set, we need to like copy it over. How can we set it to that, right? We need to get the value of it. Right, I really need to do expressions, right? Because it's not being parsed as an expression, and it needs to be. So I need to add that to the parse expression. So I'll probably do that. For now, how can I set it? I could like copy everything over. I don't really want to do that though. I just want to test the list.next and make sure it works. Can we make it a pointer? Yeah, that doesn't work. Because we cannot do that. Yeah, alright, so we're gonna have to update the way we parse expression. So we need to parse that as an expression, right? So when we do parse primary, if we encounter one of these, right, like a curly, then we need to treat it as a thing, right? I'll be right back. Yeah, give me a minute and I'll be right back. So I was thinking about it, and I'm not sure how it's going to work because we don't have access to the struct type, right? The type of what it is, so we won't necessarily know. So I need to think for just a moment about how I can do that. Because if we just did that and the value is just struct, like a generic struct, we could return that, but then we don't know what the fields are. Um, so what if instead we handle it a different way for structs? I'm not sure. I'm not sure. Right, let's go to parse primary. Let me just try it. Let me try it and see what sort of comes about. So parse primary. That's what I want. All right. So open type curve open curve. Then expr. Right. So we need to do a lot of stuff. So the expr type will equal expr struct. Right. So that is the type of it now. I don't know what it is. Right. And then the data type equals type struct. So I guess if we just have a generic type struct, it would be close enough. Like it would be prone to error, but that could be checked later on in the compilation stage, perhaps. But then we need to consume it, right? So did we consume the open one? So that is consumed, right? So that's what we have. We have the open curly, and then type struct, and we need to then basically parse a variable declaration. But it's not really a declaration. It's an assignment. Right, it's an assignment one. So how do I handle that in the structs? Because we need to do that and then basically create the stuff to generate. And we need to do that as many times as required. So it's going to be a bunch of expressions to generate. And the offsets to go with it. So I guess basically while let's do open. Let me do this. Token equals token consume tokens. So we have a token. And then while token type is not equal, token type close curly, we will continue doing this, right? Let me just sort of do something for that. So we're going to have an identifier that will consume. And then we're going to have an equal sign that will consume. And then we'll have that. But we don't know the offset necessarily. So it has to be in the correct order. Let's maybe make that a thing. It has to be in the correct order, at least for now, until I think of a better way to handle it. Let's see, whoops. Okay. If it's the correct order, we just do it as many times as we need, and the offset will just increase by the size of the thing each time, right? So we'll create a new field. I think we have one called, yeah, we do have one called field. And then dot struct name equals, we don't have the struct name. So we'll have to set that afterward. Ooh, that's going to be hard. It's going to be harder. But the field equals dot name can be token dot value dot ident, right? So we have that. Well, let me actually make this if token dot type, right? So if we do this and it's initially a curly brace, that means we're at the end, right? So at the end, so it'll just zero initialize the whole thing. Otherwise, token dot type does not equal token type ident, then we will error token dot lock expected type ident, but found that, right? So we can do that, and types token dot type. Okay, perfect. Field is this. And then we need to expect token. Tokens and token type equal. And this doesn't need to be like this actually. And then we want to what do we want to do? We want to there's going to be a value. So we need to then parse expression, right? So parse express. So the field without value equals parse expression. Right, and whatever else we have to pass there. Tokens and parts writing is it. Sure, okay. And then we just continuously do that, right? So that's going to consume all the stuff. And then we're going to, well, there should be a curly, or not a curly, but a comma at this point. But there might not be if it's the last one. So if, consume tokens, type the, equals token type curly, close curly, then we just wait. Otherwise, right, so we're good. It should be that, so we should be fine. And then we are at the end, so that should be fine. We don't have the return type for, no, we have the data type is type struct, so we need to add that actually. Add that, but that should pretty much parse the whole thing. Right, because we have a bunch of fields. So let's see. There's one compile currently, because there's some things that we need to consider. Parse expression just takes the parser, okay. Alright, we can use the append for that. The append field dot value pointer. Do that, okay. And let's see. Field has no member named, so what is it called? Is it field name? You know, field is the name of it. Let's see. Alright, what is it? Oh, it's var name. Okay. Var name. Well, is that right? Is that what we use var name for? I would hope so. The structure, we don't know what it is, so we'll have to set it afterward, which is unfortunate, actually, because that is going to be a bit hard. Will it be? So we have to set expr value dot structure. We can actually da append to that. Actually, to add a append, right? Parser arena and parser arena. Right, we want to append to that. We want to append the value of field. Like structure fields. Append that. So we don't have that currently. We'll need to make that. Well, do we have structure already? We should have a structure. Struct or something like that. So we have values. So we'll just call it values, right? So actually, maybe we don't want the identifiers, right? And then we can just have the values. Just append that, you know, just append that. Then we have a comma. We append that. We have a comma. So it's going to break some things, and it's going to change the syntax a bit, but it would be something like this. So, you know, you'd have list equals 1, 2, 3, right? You could do that. And that's it. So I think that's probably even better. Yeah. So it's going to make it a bit more restrictive, but if you want to assign to a specific thing, you can just do, yeah, you can just do like what? Yeah, list dot next equals whatever, right? You can do it like that. If you want to be more specific about it. At least for now. At least for now. So let's do that then. Let's get rid of this. Let's get rid of this. We don't need the field anymore because we just have the values. Just have the values. Values, so we'll append to those. And we don't need equal. Yeah, so we basically do this. You know, we append that. So we don't need the field because we can just append the parts expression. Right, you just move that up here, and there we go. So then that's it, right? Just until there's a close, we'll just do that. Okay. And then the value has no value. Oh yeah, so we need to add it to extra value. And we have what? So we do have field, but we don't want that. We want structure. So structure, and let me look at the structure again because I was just looking at it. But so it has that, and then the string view name, and that's the name of the structure, which we don't have yet. Values. Where is it? I added that. expert value. Oh yeah, we need expert type as well. Type. So this will be expert struct. Okay, because this is a struct definition, right? Customer member values. It's something that's not a structure unit. Why is that? Expert value dot structure. Value dot structure. Expert value has structure. Okay, there we go. I just had to refresh it. Struct is not declared, so we can't actually do that. But can we move the structure up? Struct. Yeah, I don't think that will use anything that we do not have. Right, at least right here. Struct, there it is. Dang. So then we have a lot more issues. I'm going to type in nodes. And I just use struct nodes. Alright, that is not good enough. So, can I move the nodes up? Yeah. So I use a struct node, but that we don't define it until up here, right? So that should be fine. Right, I have to move stuff around because it's very dependent on that. Hopefully that will work. Okay, and then we have this. So, alright, so now it broke everything. 625. Is it all 625? Yeah, it's here. So plus arena, it's value. It's into a pointer. And incredible types. Oh, shoot, because that's a list of nodes, not expressions. Shoot, okay. Can it be an arg value? Because that's basically what we want. But what is the difference? So where is struct? Hang on. Struct. Nodes. It has nodes. What are the nodes? The nodes are basically... It's not... Okay. I'm gonna do that. Get rid of this. Let's see. So what else could we use that is not that, right? What was it? Arg value. I'm just gonna use that, you know? Arg value. Structure. Right, so this would be arg value. It doesn't really make a lot of sense, but the name makes it make more sense, right? Arg value. I don't know what it's called. Oh shoot, it's defined down here. Frick. Up here. Gotta move everything around. Aw. Arg value. Get rid of that. We have these problems again, so it's not like that. Expert. Struct. Expert. Shoot, but that's supposed to be a... Yeah, well, it can just be a single one. Because we don't need... No, we do need more than that, so that's not even going to work anyway. So, did that for nothing. Let's make a new structure, right? New one. So it's going to be... We already had structure. Oh yeah, so structure, that's what we use. Yeah, it's not very clean, but... Structure. Okay, that's going to have view, name, and then struct experts. Actually might not have experts yet. Well, we should, right? Arg value, that's not what we're using. We are using structure, and I spelled it wrong. Structure. Okay. We do not have type. We don't have the right one. Type, what is defined at? We use it a lot. We should use type struct. Well, it could just be type pointer as well. It's basically a pointer. Well, it is a pointer. So maybe we'll use that instead. We want to be more specific though. Alright, we do that then. And then when we return it, right, so now when we are actually declaring a struct, so is struct, right, when we declare it, we want to, we don't want to expect an open curly. Now we can just place the expression. We can set the value as that, right, but we do have to do other stuff first. So let's maybe, for expert equals parse expression, parser, that's what we need to pass. And then I will just, comment some of this stuff out for now. Okay, do this, and so parse the expression. Okay. And what else? What else? What else? What else? What else? Parse the expression. Iterate over the entire thing. So for right, and then actually we need to check the data type. So if extra data type does not equal type pointer, then print error no dot location expected right, so then that's gonna be actually, yeah, it's gonna be an expert. So expected struct. Right, so let's put that for now. And then iterate over the expert value bar. No, expert value dot structure dot count value dot count. And why is this? Okay, and then we want to just set do we even need this actually? Because we already have the structure type from the actual thing itself, so we don't even need to do that actually. But yeah, then we just append that there, and that's it, right? So let me compile that. There's some issues that need to be a pointer. There we go. Okay, so now we can't actually compile it yet, so we need to add that to the backend. Gen expert. So we need a case of expert struct, and we can basically handle it like how we are currently handling structs, right? So let's do var deck. Struct. We have struct somewhere. Structure. Field reassign. That's not what we want. Let's see. Instructions. That's not it. Get the struct. Struct Alex. We can call that, but where do we call it? Struct Alex. Where do we call it from? Alright, var deck. So we have this. If it is struct. Wait, no, but hey, we're not. Well, okay, now we can just gen expression. Right? So that's what we need to do actually. So we get the structure. We don't have to do that. We can just okay, why is it messed up? Or whatever. Gen expression of node value dot bar dot structure dot values dot values. So we need to iterate over each one. For size I equals 0, I is less than node value dot bar dot structure value plus. And let's see here. So we do that. Actually, we don't have to do that because we have, well, yeah, we have each individual one, so we could do that. And then we could just handle it on our own. Yeah, that makes sense. So we can get the structure here. Right, so the value of it is that, though. So that's not necessarily right. That is not right. Okay, let me go back to here. Dot is struct. So, expert. And it's just one expression. Yes, that's not even a word. Is a single one. So we need to gen that. But first we have to set it. So let's set node value bar. What is it? We need to set the expression. Node value dot var dot value equals expert. Whatever we need to set actually. Let's see, where's that compile? Remember named structure. But yeah, so the other stuff does not give an issue. So value dot var dot value. So we need to parse that. So we do actually have to give it that value. The value of the struct name. We can do that here because we have the current struct. 0 y is less than node.value dot var dot value. Var dot. We don't have var dot structure though. We have value there. Var dot value dot structures dot values dot count. Do I plus there and make sure that will succeed. That is an arrow because it's pointer. And let's see, so that's expers. I don't understand why it's so messed up here. What the heck? Right. Yeah, it's a little messed up. The indentation. Okay. So, right. Value dot structure values. But that is as well that. So, shoot. Actually, do we? Var dot value. Hang on. Too few arguments to that. So, wait, what else do we have to pass? We have to pass state. And that. Expers has no value named structure. Right. The value though. Why is it expert? But it allows me to set this equal to the single expert. Where do we set the value of it here? Append the symbols. Value dot var dot value. No dot value dot var dot value. Node value var value. Why does it not? Right. Yeah, why does it not complain about that? I don't understand. Theta 0. Right, we don't want to just do the 1. Yeah, okay, there now it complains. So there was. I guess we could really append to it. To add append. So arena node value var value expert. So we should only have the 1. Parser dot arena. Okay, so if we use that, we gen the expression here, but first we need to set it. So for I equals 0, well, I is less than node value dot var dot value dot data 0 value dot structure dot values dot count. I plus plus. Does that succeed? Arrow, okay. Does succeed. Okay, and then we need to set it. So node value dot var dot value dot data 0 dot value dot structure value dot data I dot name equals current struct dot name. That's a pointer again. I just want to well. Yeah, it's dot data value var dot name. Value. Shoot, how do we set that? Binary. Let's look here. So open curly, and we set that. We just append that, so we don't have a structure name. Right, because that's all it has. Value structure. Structure has a name, so we need to set the name of the whole thing. Hang on. Dot structure dot name. Dot structure dot name. Is that right? Okay, struct. What else do we call it? Dot value dot structs. Okay, so I guess so. Gen that, and then we can we don't really need to do this. We can move this into there. So assume that we have that. So we can just generate it and generate the offset. So we'll have to complain about it, but we'll do that later. So let me just grab this. Yeah, I'll just grab it and go to gen expert. Gen expert, and we have expert struct, and we want to do all of this stuff, right? So let's see, let's get rid of all of it. One more indent. Okay. So alloc size. And this needs to be again, and this as well, and this needs to be that. Okay. So gen struct alloc. So we allocate the structure. We don't have the current struct, so we actually want to do this back there. So we need to do that back. Struct. Right, so we can do that before we gen any expression. Generate that, and then the rest of the stuff can be done. Struct. No, expert struct. Yes, we can get rid of this, and what we want to do here is, let me make sure I put that back though. Gen struct alloc. Do we have that? Yes. Okay. I was just making sure because I didn't remember. Expert struct. Yeah. So we iterate over that. We'll just do that. So do we have the? We just need to basically gen the expression each time. So we just iterate over the count and generate that, and then we have to, yeah. So we don't want current struct. We want expert value structure values by count, and then I don't know what this is. Gen struct value. Struct value. What does that expect? Field position, node, field, and node value. So we're gonna do that a bit different. Void gen structure field. Hopefully we don't have that program. State. And then we just need the expression, right? I just want to gen extra. So, alright. This is going to, yeah, it's going to remove it from the top of the stack. So we want to do that for sure. So we want to generate an offset. So maybe we'll have the offset. We'll do times whatever the, we'll accumulate the offset and pass it. That should be okay. So we want to gen expert, state expert, okay, generate that. But first we want to generate the offset. So we can generate this offset. What? Oh, that's the position of the, okay, of it within the field. So we don't necessarily want to do that. We want to push push state offset, right? And then we want to gen add state, right? We want to do that. So that will create the offset essentially, I think. And then what to do to repeat state, right? And then cast it to a word pointer, generate the expression, and then write it, right? So we need the size of the expression though. Oh, but we have the type though. Generate expression. So data types extra type, and that is what we want to push. So gen push data type size expr type and state. Okay, so that will get us the size of it, and that is the offset that we'll have. Okay, generate expression and push that. I'll do that first. No, we don't want to. We want to do it after, and then we want to write. And write state. Okay, and that should be pretty much correct, hopefully. Let's do expr struct. So I want to call this function. So let me grab it actually. Expr struct. Alright, so gen structure field pass the state. The offsets, we're going to accumulate the offset. Say equals 0. Offset plus equals data type size of expr value dot structure value dot data I dot data type. Okay, so plus equals that. Yeah, now we just accumulate, right? So then we can pass the offset here. And the expression is this. Expr value dot structure dot value dot data I dot that's it dot value. Something like that. So let's try to build that. Shoot. And I forgot a closing thing somewhere. Structure field. I move a closing from here. Oh shoot, that's gonna be kind of hard to. That's right. Must have messed it up somewhere. Or did I forget to? Yeah, I did this wrong. I'll tell you that. Okay, gen expr. Expr value. Value. What? Okay. No, it's a. I'm gonna pass each individual value, so let me look at that. So we append to expr value, structure values. Structure values. Data I, and that's it. But we don't have, so then we need the data type of that. Okay. That's an arrow. Okay, plus the declaration of that. So that needs to be gen TVP. Okay, gen pop. Alright, I guess I just need to fprintf. No, not fprintf. We need to append one of those. So do we have gen TVP? What do we do for that? Word pointer. We don't do that anymore? What? Alright, we do this. It should really be that, but okay. It would be a function. If your elements to push, so push specs the machine. So is that not in the state? We don't have the machine, so we need machine. This is supposed to be gen push. That is where I am wrong. Gen push. Okay, so I can compile now. Expected that, but done that. Alright, so it is not like that. Int string char or ident, but found that. So why is that? Oh, shoot, because we don't expect. We need to expect it up here as well. Right? It's not equal token type. Right, we don't really need to check all this, but you know. Oops. Oh shoot, we did not consume the equal, did we? Let's do assign. No, and this is what's our dex. We need to consume the equal in here for this one. So expect token. Tokens don't type equal. Okay, forgot about that. And it is not equal, it is that. What the heck? What do you want from me? On line 10. And if I get rid of all that, just have this. Then that works. Okay, and if we exit with this data, does it work? Here's 12. Okay. Then when I try to find another one, so this equals that. That doesn't work. Oh shoot, it's because I was doing it wrong. Yeah, of course. So I need to put like that. Yeah, so you can do that. So we can do next. We can't really define, well, if we define this first, right? And then list.data equals 15. We set this equal, let's see, when I set it to list and 12. We exit with list.data. Alright, so we did not consume that properly, so parse expression. Parse primary. Well, let's just look for expert struct, right? Yeah, so we need to let's see, where is it? 11, 19. Why did it fail? We do consume it. Let's see, so we can consume that, and do we not want to consume that? No, that's the open curly that we're consuming, unless did we already consume that? We did, so we don't want to consume. Token equals token peak. Token 0. That's what it was. We were consuming it incorrectly. Expected, unexpected token, that. What? Okay. So we peek the top one. There should be a close. Oh shoot, but then we need to token on the city. Right, so we can't really quite do that. So, right, so this is, it gets a bit more complicated. So, tokens, it's not equal token type. And token allocation, expected, comma. Okay, then we can just token consume it again. It's actually that needs to be token 0. Yeah, okay. Not type. Else if index out of range. Alright. So I think that was a runtime. Yes, okay. So something is wrong when we are generating it. Shoot, that is gonna be kind of hard to debug. Not GDB, but dot slash Tim fire build fire Kano.tim. Do that, and let's disassemble it, and it's pretty long. We don't want to just try to make some text, so Kano. Let's get rid of some of this extra stuff that we don't really need. Right. So we can have just this. So actually, this being defined incorrectly. Are we consuming too much space for this data type? Are we consuming not enough? So, if we just do this, that would work, right? We exit list.data. Okay, and then if we declare another list, so list equals that, and we set list.next equals list. That all works. Let's set the, well, we can't really set the data yet, that's the problem. But we can set list.data equals 57. That's still 15. Oh yeah, there's a couple issues. I'll need to work on it. But list, that will be 57. Okay. And if we set temp list equals list.next, then we should be able to do temp.data should be 15. Expected struct definition. Why expected struct? Okay, so it's not a type pointer. So what is the type of it? Hang on. What is the type that this returns? Or it could be one of those. So what is the, can I print out the type? What if I run GDB on? Okay, and that's just gonna die, right? But if I break on this point, right? Break front-end.c 931 and run. And once we get there, next, and let's print expr on value for data type pointer. Okay, so that's fine. Continue. Expr.data type pointer. That's fine. Continue. Expr.data type int. Okay, why is it type int? Why is that the type that returns? Next is type int. What? Should be why is it that? Well, type. Let's see. That's not a variable. I don't know why it would be an int. So maybe I will actually try that again. GDB.main, enable, break on 931, and .c at 931, and then run, and let me see, I think it's 3, right, that we have to go through. So, continue, expert data type is that, alright, so it's that one actually, so it's 2. I'll run it again. Continue, and let's step into this, and let's see what happens. Continue. Huh? Why did, oh shit, I pressed continue now. That was my bad. Continue, step. Next. Go here until we call so we get var, get structure to consume. Let's see, to consume. This is a structure, so I don't know. It's a field though, so expert field. So we don't set the data type. That's what it is. Okay, we need to set the data type in the field. So we set the data type equal to that, but let's set the data type equal to a pointer. Can we do that? Let me see, what line is it? 684. Right, because, well, hang on. The field data type should be that, though. Why is that the data type? Hang on. Expo.data type is int. And print structure value data I value var type. Print structure values data I. That's not gonna, okay. Print structure values data I value. Try that again. Values data I value var. Okay. So values next. Why is the data type int? Oh, but it's a structure. Yeah, so it's a structure. But why did we set, so the data type should be a type pointer in that case, if it is a structure when we encounter it. So we need to change that. So that's in the variable dec, right? Our dec. It is struct, when we set that. But then, our dec, when we call this down here, it is struct, then we do that. Shoot, but we need to parts primer. Let's do, okay, hang on. This is the variable declaration, not this. Oh yeah, it's type struct. I forgot. That's what we want. So here, we want to set the data type of that. Where do we set that? We parse the variable declaration here. Yes, that's what we gotta do. Where do we? Node value var dot type. Node value dot var dot type equals token that equals type pointer. That's it. So that should be good then. Expected struct definition. So expected that. Okay. Why? So it's an int before because that's just the default type. But why is this not? Why is that still an int? Definition found. Data types. Server type. Okay, let's set that. Make a line for this because it's getting kind of long. View arg. Zoom out a little. Okay. If I think the data types are messed up. Data types. Okay, so I need to do that. Data types. Would that be if? What? There is no if. Just do dot data though. I do that. Does it say it's an if? I don't get that. Let's pass it to the PH. There we go. And then it's false. Okay. Yeah, I'm having some issues. I'm gonna need to come back to this. Yeah, because I do have to go now. So let me do work in progress. Definitions as expressions. Yeah. Getting there, getting there. But yeah, that's gonna be about it for today. So thank you guys for watching, and I'll see you next time.